Alright, so today I built a little DC pulsing circuit. So I switch enhancement mode MOSFET. It's an IRF P460A to be exact. I only have one. The circuit's built to handle up to 4, but I've blown tons of the little ones, so I only have this big one on there right now, mounted on a big old heatsink. And I got a fan going on it, and it pulls 60 milliamps. So this light over here takes about 200 milliamps to power on fully. So this is when the circuit's not being driven. We'll see the amp draw when I do drive it. I can drive it up to like 2.5 amps, but basically this MOSFET won't last very long if I do that. So I just think the efficiency that's going on here is a lot better than the last video using DC pulses, because there's a lot of energy that's lost in the motor to turn it to make the generator side. So here's the circuit I'm using now, and still 13.8 volts and regular AC ground, so in the iron pipe like last video. Instead, I found out that these mica capacitors actually work way better than the electrolytic one I was using before. So we'll go ahead and turn it on and we'll watch our light bulb. Now the light bulb doesn't get fully lit, but it gets pretty bright compared to the last one. So right there, it hits some resonance and we're pulling 270 milliamps. And so that's about 200 milliamps that we're putting in here, and we're getting a lot of it out right here. So that's pretty efficient through a bunch of capacitors. That's the only thing, and you know, so if we unplug this, you can see the light goes out, right? So this is exactly what a Tesla coil does, except it's with a Vortex coil. And the cool thing is I'm not using high voltage, and we can still transmit power through the ground. And I think DC pulses are where it's at. AC makes two induced fields. So when we pulse this DC, we basically create a magnetic field, and then we allow nature to create the opposite magnetic field, which is the type of energy associated with the environment. Thus, we put electricity through the environment and pull it out through the ground with resonance. Now the only plus to having high voltage is I'd be able to make this a big elevated capacitance rather than have it directly connected through a bunch of capacitors. So that's pretty good. I mean, we could play around with it and watch the amp draw. I'm not sure if you can hear that, but really small pulse is where it's at, and right there is the best. And this is a scope reading. I don't know if this is going to do much. But we got, this is my driving signal. And this is the, this is a signal on the secondary receiving coil. So, I don't know what that really tells us, but it's oscillating, and it's oscillating pretty oddly. But it oscillates at a range of frequencies. This is one that I've found that works best for transmitting through the ground. Yeah, so I'll post a couple more videos coming up with, I'm going to set these two coils into resonance with my one bigger coil. So more to come. Thanks for watching.